Welcome to the Powerline Technician Red Seal exam practice. This video contains 125 practice questions to help you prepare for your certification exam. Let's begin. This exam covers the following major work activities: common occupational skills, installs structures, installs conductor systems, installs auxiliary equipment, and performs operation, maintenance, and repair. Before we start, if you're preparing for your Red Seal exam, hit subscribe. We cover over 50 trades. Question 1. What class of rubber insulating gloves is rated for a maximum use voltage of 17,000 VAC? A. Leather protector gloves worn as the outer shield for mechanical protection. B. Neoprene chemical-resistant gloves designed for transformer oil handling tasks. C. Class 2 gloves rated for a maximum use voltage of 17,000 VAC. D. Flame-resistant gloves worn inside arc flash protective clothing ensembles. The correct answer is C. Class 2 rubber insulating gloves are rated for a maximum use voltage of 17,000 VAC. Leather protectors provide mechanical protection but no dielectric value. Neoprene gloves resist chemicals but are not voltage rated for live line work. Flame-resistant gloves protect against arc flash heat but do not insulate against electrical contact. Only rubber insulating gloves in the correct class provide the required dielectric protection for energized work. Question 2. What must be worn over rubber insulating gloves to protect them from physical damage during power line work? A. Cotton liner gloves designed to absorb moisture and perspiration. B. Neoprene chemical-resistant gloves to prevent surface contamination. C. Kevlar cut-resistant gloves to guard against sharp pull hardware. D. Leather protector gloves to shield against punctures and abrasion. The correct answer is D. Leather protector gloves must be worn over rubber insulating gloves to shield them against punctures, cuts, and abrasion from hardware, conductors, and pole surfaces. Without leather protectors, the rubber gloves can sustain damage that compromises their dielectric integrity. Cotton liners may be used underneath for comfort but do not replace leather protectors. Question 3. What is the primary purpose of establishing minimum approach distances, MAD, when working near energized power lines? A. To define the boundary where arc flash protective clothing must be upgraded. B. To calculate the required length of rubber line hose for conductor coverage. C. To prevent workers from entering a zone where electrical flashover could occur. D. To determine the appropriate size of traffic control zone around the immediate worksite. The correct answer is C. Minimum approach distances prevent workers from entering a zone where electrical flashover could occur between an energized conductor and a grounded object or person. MAD values increase with system voltage and account for factors such as altitude, switching transients, and tool reach. Violating the MAD boundary exposes workers to potentially fatal arc flash and electrocution hazards. Question 4. A Powerline technician crew arrives at a worksite after a severe ice storm and finds broken tree limbs resting on a downed conductor. What should the crew leader do first? A. Contact the control center to confirm the circuit is de-energized before approaching. B. Set up traffic control and use a hot stick to move the branches off the conductor. C. Begin clearing the tree limbs by hand after donning Class 2 rubber gloves. D. Request a helicopter patrol to survey the full extent of damage on the circuit. The correct answer is A. Contacting the control center to confirm the circuit status is the critical first step because a downed conductor may still be energized or could be re-energized by automatic reclosing devices. No crew member should approach until the circuit is confirmed de-energized and isolated. Environmental hazards from ice storms compound the electrical risk, making positive confirmation of isolation essential before any physical work begins. Question 5. After a circuit has been isolated for lockout-tagout, what must a Powerline technician do before contacting any conductor? A. Test the conductor with an approved voltage detector to verify absence of voltage. B. Notify all adjacent property owners of the planned maintenance outage. C. Remove all automatic reclosing devices from nearby adjacent poles. D. Install temporary protective grounds at the immediate worksite location. The correct answer is A. Testing with an approved voltage detector to verify absence of voltage is mandatory after isolation and before any contact with the conductor. This step confirms that the isolation was effective and that no backfeed, induction, or capacitive charge remains on the line. Only after verified absence of voltage should temporary protective grounds be installed as the next step in the safe work procedure. Question 6. When installing temporary protective grounds on a three-phase distribution circuit, which connection must be made first? A. The connection to the first phase conductor closest to the climbing worker. B. The connection to the cluster bar or ground bus attached to the neutral. C. The connection to the system ground electrode installed at the pole base. D. The connection to the bracket ground clamp on the steel crossarm surface. The correct answer is C. The connection to the system ground electrode must be made first to establish the ground reference before any phase conductors are contacted. This ensures that if an unexpected energization occurs during the grounding process, the fault current has a path to ground rather than flowing through the worker. Phase conductors are connected after the ground end connection is secure, working from the bottom up. Question 7. A technician is installing equipotential grounding on a transmission structure and notices the ground cable is warm to the touch after connecting the first phase. What is the most likely cause? A. Induced voltage from a parallel energized circuit is causing current flow through the cable. B. The ground rod connection has excessive resistance caused by dry soil conditions. C. The ground cable gauge is undersized for the available fault current capacity. D. The cluster bar clamp is making intermittent contact with the phase conductor. The correct answer is A. Induced voltage from a parallel energized circuit is the most likely cause of current flow through the ground cable during installation. Transmission lines running in close proximity can induce significant voltages on de-energized conductors through electromagnetic coupling. This induced current flows through the grounding circuit and heats the cable. The technician should verify the ground cable capacity is adequate and consider additional grounding points to reduce the current per cable. Question 8. What is a powder-actuated tool commonly used for in powerline construction? A. Driving pins into concrete or steel to secure grounding conductors. B. Compressing hydraulic connectors onto stranded aluminum conductors. C. Cutting hardened steel bolts and fasteners on crossarm assemblies. D. Drilling pilot holes through wooden poles for lag screw installation. The correct answer is A. Powder-actuated tools use an explosive charge to drive hardened pins into concrete, steel, or masonry. In powerline work, they are commonly used to fasten grounding conductors, cable supports, and conduit clamps to concrete structures or steel beams. Operators must be certified in their use and must inspect the tool and select the correct powder charge for the base material. Question 9. Before using a hydraulic compression tool to install a connector on an aluminum conductor, what must the technician verify? A. That the hydraulic fluid reservoir is filled with the correct silicone-based lubricant. B. That the compression tool has been calibrated within the past 30 calendar days. C. That the die set matches the connector size and conductor type specified by the manufacturer. D. That the conductor temperature has stabilized below 40 degrees Celsius before compression. The correct answer is C. Verifying that the die set matches the connector size and conductor type is essential before compression. Using mismatched dies produces an improper compression that can result in high-resistance connections, conductor pullout, or joint failure under load. The connector manufacturer specifies the exact die number for each combination of connector catalog number and conductor size. Question 10. What instrument is used by a powerline technician to confirm that a circuit is de-energized before beginning work? A. A clamp-on ammeter to measure any residual load current on the conductor. B. A high-voltage proximity detector or direct contact voltage tester device. C. An insulation resistance tester to check the conductor insulation integrity. D. A phase rotation meter to verify the correct three-phase sequence order. The correct answer is B. A high-voltage proximity detector or direct contact voltage tester is used to confirm that a circuit is de-energized. Proximity detectors sense the electric field around an energized conductor without direct contact, while direct contact testers provide definitive proof of voltage absence. The tester must be proven on a known energized source before and after use to confirm it is functioning correctly. Question 11. When using a phasing stick to verify phase-to-phase voltage between two circuits, what does a zero voltage reading indicate? A. That the two conductors are on the same phase and can be safely connected. B. That the phasing stick internal batteries are depleted and require replacement. C. That a high-resistance fault condition exists between the two tested conductors. D. That both circuits are fully de-energized and safe for protective grounding. The correct answer is A. A zero voltage reading on a phasing stick indicates that the two conductors are on the same phase and can be safely connected or paralleled. Phasing sticks measure the voltage difference between 2 points. If both conductors are at the same phase angle, the potential difference is zero. Before connecting circuits, confirming identical phase is critical to prevent a phase-to-phase short circuit that could cause equipment damage and a safety hazard. Question 12. When rigging a transformer for crane installation on a pole platform, what must the technician confirm about the lifting slings? A. That the slings are made exclusively from synthetic nylon webbing material. B. That the slings are color-coded to match the transformer voltage class rating. C. That the slings have been stored in a climate-controlled sealed container. D. That the slings are rated for at least the full weight of the transformer unit. The correct answer is D. The lifting slings must be rated for at least the full weight of the transformer, including any oil or accessories. Exceeding the working load limit of a sling can cause catastrophic failure during the lift. The technician must inspect slings for cuts, abrasion, and heat damage, verify the rated capacity on the tag, and ensure the proper sling angle is used. Sling material varies by application and is not restricted to nylon. Question 13. During a pole replacement, the rigging crew notices the crane load indicator reads 85% of capacity while lifting the new pole. The pole still needs to be boomed out 2 meters further to reach the hole. What should the crew do? A. Continue the lift slowly and monitor the load indicator for any further increases. B. Add additional counterweights to the crane base to increase the rated lifting capacity. C. Stop the lift and reposition the crane closer to the hole to reduce the boom radius. D. Tilt the boom to a steeper angle to reduce the horizontal load on the crane frame. The correct answer is C. Stopping the lift and repositioning the crane closer to the hole reduces the boom radius, which increases the crane's available capacity at that radius. Crane capacity decreases as boom radius increases, so extending the boom further at 85% capacity would risk exceeding the rated load and causing a tip-over. Repositioning is the safest corrective action. Adding counterweights or continuing at near capacity are unsafe practices that violate crane operating procedures. Question 14. On a utility construction drawing, what does a solid triangle symbol typically represent? A. A lightning arrestor installed on the distribution pole. B. A down guy anchor point and the direction of the guy wire. C. A three-phase transformer bank location on the circuit. D. A sectionalizing switch installed on the mainline distribution feeder. The correct answer is B. A solid triangle on a utility construction drawing typically represents a down guy anchor point, with the triangle pointing in the direction of the guy wire. Understanding standard utility drawing symbols is essential for interpreting staking sheets and construction plans. Transformers, arrestors, and switches each have their own distinct symbols as defined by utility drafting standards. Question 15. When interpreting a staking sheet for a new distribution line, what information does the technician use to determine the correct pole class? A. The conductor size, span length, and expected wind and ice loading conditions. B. The number of street lights and transformer units assigned to each individual pole. C. The color coding on the staking sheet legend for residential versus commercial zones. D. The distance from the substation and the anticipated voltage drop at peak load demand. The correct answer is A. Conductor size, span length, and wind and ice loading conditions determine the mechanical stresses on the pole, which dictates the required pole class. Heavier conductors, longer spans, and higher loading districts require stronger poles with higher class ratings. The staking sheet specifies these parameters, and the technician references pole loading charts to select the appropriate class. Question 16. What is the primary reason for conducting a pre-job safety briefing before starting power line construction? A. To distribute specialized tools and assign personal inventory lists to crew members. B. To confirm the material delivery schedule and arrange for temporary storage areas. C. To verify that all crew members have completed their annual certification renewals. D. To identify hazards, review safe work procedures, and assign crew responsibilities. The correct answer is D. A pre-job safety briefing identifies site-specific hazards, reviews the safe work procedures for the tasks ahead, and assigns clear responsibilities to each crew member. This tailgate meeting ensures everyone understands the scope of work, emergency procedures, and their individual roles. It is a mandatory step before beginning any power line work and must be documented. Question 17. When planning a conductor stringing operation across a highway, what must be arranged in advance with transportation authorities? A permit for temporary road closure or flagging to protect the public during stringing. B. An exemption from overhead clearance requirements during the tensioning phase. C. A variance allowing crew vehicles to park on the highway shoulder for the duration. D. A weight restriction waiver for the real trailer to cross the highway bridge deck. The correct answer is A. A permit for temporary road closure or flagging must be arranged with transportation authorities before stringing across a highway. The conductor will temporarily occupy the road right-of-way during pull and tension operations, creating a public safety hazard. Traffic control plans, flagging personnel, and signage are required to protect motorists and pedestrians during the operation. Question 18. A technician is planning a pole replacement on a circuit that feeds a hospital. The utility requires 0 unplanned outages. What approach should the technician plan? A. Schedule the work during the hospital's lowest patient census for a brief outage. B. Request the hospital activate its backup generators and proceed with a planned outage. C. Install the new pole beside the existing one and change over while energized. D. Transfer the hospital load to an alternate feed before de-energizing for replacement. The correct answer is D. Transferring the hospital load to an alternate feed before de-energizing the circuit ensures continuous supply to a critical facility during the pole replacement. This approach eliminates the risk of an outage to the hospital, which is the overriding planning requirement. While hospitals have backup generators, relying on them for a planned utility maintenance activity is not best practice when an alternate feed is available. Load transfer is the standard method for maintaining supply to critical customers during planned work. Question 19. Before climbing a wooden utility pole, what must a Powerline technician do to assess the pole condition? A. Perform a visual inspection and sound test by striking the pole with a hammer. B. Measure the circumference at the ground line using a calibrated diameter tape. C. Drill a core sample at 300 mm below ground level to check for internal decay. D. Apply a fresh coat of wood preservative treatment to the climbing zone surface. The correct answer is A. A visual inspection combined with a sound test by striking the pole with a hammer is the standard method to assess pole condition before climbing. A solid pole produces a sharp, ringing sound, while a decayed pole produces a dull, hollow thud. This pre-climb inspection detects shell rot, woodpecker damage, and ground line decay that could cause the pole to fail under the added load of a climbing technician. Question 20. What type of fall protection must a Powerline technician use when working from a wood pole above 3 meters? A. A fall arrest harness with a shock-absorbing lanyard firmly attached to the pole. B. A positioning belt with a secondary safety strap worn at all times on the pole. C. A chest harness with a retractable lifeline connected to a ground-mounted anchor. D. A full body harness with a work positioning lanyard that wraps around the pole. The correct answer is D. A full body harness with a work positioning lanyard that wraps around the pole is required for Powerline technicians working at height on poles. The work positioning lanyard encircles the pole and allows the technician to lean back and work with both hands free while being supported. Applicable safety standards mandate the use of a full body harness rather than a belt-only system for fall protection in the utility industry. Question 21. When positioning an aerial device, bucket truck, to work on a distribution pole, what is the maximum allowable ground slope for safe operation? A. Any slope is acceptable provided the vehicle parking brake is fully engaged. B. The slope must not exceed 5 degrees or as specified by the equipment manufacturer. C. The slope must not exceed 15 degrees with outriggers extended on solid pads. D. The slope must not exceed 10 degrees with wheel chocks placed on the downhill side. The correct answer is B. The maximum allowable ground slope for aerial device operation must not exceed 5 degrees, or as specified by the equipment manufacturer. Operating on steeper slopes risks tipping the unit, especially when the boom is extended and loaded. The technician must assess the ground conditions, extend all outriggers on firm pads, and verify the unit is level before raising the boom. Manufacturer specifications always take precedence. Question 22. What is the purpose of a capstan winch mounted on a line truck? A. To generate hydraulic pressure for the aerial boom lift system on the vehicle. B. To pull conductors, cables, and equipment using a rotating drum mechanism. C. To anchor the truck during pole setting operations in soft or wet soil conditions. D. To stabilize the truck frame when operating the boom on uneven terrain. The correct answer is B. A capstan winch is a rotating drum mechanism mounted on a line truck used to pull conductors, cables, and equipment. The operator controls the pulling force by wrapping the rope around the drum with a specific number of turns. Capstan winches are essential for stringing operations, pulling slack, and positioning heavy equipment. They provide controlled, variable speed pulling force. Question 23. When installing cover-up on an energized distribution line, in what order should the protective equipment be applied? A. Start from the work area and apply cover outward toward the nearest grounded objects. B. Apply blankets to the lowest voltage conductor first and work upward through phases. C. Cover all 3 phases simultaneously using a pre-assembled insulating blanket set. D. Cover the grounded hardware and neutral first, then cover the energized conductors. The correct answer is D. Cover-up must be applied to grounded hardware and the neutral first, then to the energized conductors. This sequence ensures that the closest grounded objects are insulated before the technician works near energized parts, reducing the risk of a face-to-ground flashover through the worker. Removing cover-up follows the reverse order: energized conductors first, grounded objects last. Question 24. What is the purpose of a line hose in live line cover-up applications? A. To carry pressurized hydraulic fluid to the aerial device boom control system. B. To protect underground cables from moisture ingress during direct burial work. C. To insulate an energized conductor by wrapping it with a flexible rubber tube. D. To ventilate enclosed spaces where technicians perform cable splicing tasks. The correct answer is C. A line hose is a flexible rubber insulating tube that wraps around an energized conductor to provide temporary insulation during live line work. It prevents accidental contact between the covered conductor and workers, tools, or other conductors. Line hoses are applied using hot sticks and secured with pins or clamps to prevent slippage during the work activity. Question 25. When performing rubber glove work on an energized 25 kV distribution line, what is the technician's primary concern regarding contact? A. keeping the boom of the aerial device grounded through the outrigger system at all times. B. Maintaining insulated glove contact with only one phase conductor at any given time. C. Ensuring the conductor temperature does not exceed the rubber glove rating threshold. D. Preventing tool handles from directly touching the fiberglass bucket liner surface. The correct answer is B. Maintaining insulated glove contact with only one phase conductor at a time is the primary concern. The rubber glove method relies on the technician being insulated from ground and touching only one phase at a time. Contact with two phases simultaneously, or with one phase and a grounded object, would create a current path through the worker. The insulated bucket of the aerial device provides the ground isolation, while the rubber gloves provide the phase-to-ground insulation. Question 26. How often must rubber insulating gloves be electrically tested to maintain their certification for live-line use? A. Every 6 months from the date of the last electrical test as required by standards. B. Every 12 months from the date of manufacture regardless of how often they are used. C. Every 3 months if used daily on energized conductors rated above 750 V in service. D. Only after visible damage is observed during the required pre-use inflation test. The correct answer is A. Rubber insulating gloves must be electrically tested every 6 months from the date of the last test, as required by Workplace Electrical Safety Standards and Rubber Glove Testing standards. This periodic testing detects microscopic defects that develop through use, UV exposure, and aging, which are not visible during a visual or inflation test. Gloves that have exceeded the 6-month interval must be removed from service until retested and recertified. Question 27. In bare-hand live-line work on transmission lines, what must the technician be bonded to before touching the conductor? A. The steel lattice tower through a conductive bodysuit and the tower ground wire. B. The helicopter skid through an equipotential grounding cable and static lead. C. The insulated boom tip through a calibrated static discharge resistor device. D. The energized conductor through a conductive suit and bonding lead connection. The correct answer is D. In bare-hand work, the technician must be bonded to the energized conductor through a conductive suit and bonding lead to bring the worker to the same electrical potential as the conductor. This eliminates the voltage difference between the worker and the conductor, preventing current flow through the body. The conductive suit, Faraday suit, shields the worker from the electric field, and the bonding lead establishes the electrical connection before direct contact. Question 28. What inspection must be performed on fiberglass reinforced plastic, FRP, hot sticks before each use on an energized circuit? A. A visual and tactile inspection for contamination, surface damage, and moisture. B. A load test at 85% of the rated mechanical capacity sustained for 30 seconds. C. An infrared thermography scan to detect internal delamination or void defects. D. A dielectric withstand test at twice the rated voltage sustained for 60 seconds. The correct answer is A. A visual and tactile inspection for contamination, damage, and moisture must be performed on FRP hot sticks before each use. The technician wipes the stick with a clean cloth and checks for cracks, chips, tracking marks, or a waxy or sticky surface that indicates insulation degradation. Surface contamination from dirt, salt spray, or moisture can create a conductive path along the stick, reducing its insulating value and endangering the worker. Question 29. How should FRP hot sticks be stored when not in use to maintain their insulating properties? A. Standing vertically in open bins exposed to air circulation for moisture evaporation. B. Suspended horizontally on padded racks in a dry enclosed compartment on the truck. C. Wrapped in conductive foil bags to shield them from ultraviolet light degradation. D. Submerged in transformer oil to prevent surface oxidation of the fiberglass material. The correct answer is B. FRP hot sticks must be stored horizontally on padded racks in a dry, enclosed compartment to prevent warping, contamination, and UV degradation. Horizontal storage eliminates bending stress from the stick's own weight, padded racks prevent surface damage, and the enclosed compartment protects against moisture, dust, and sunlight. Proper storage is essential to maintain the dielectric integrity of the FRP surface. Question 30. While performing cover-up on a 14.4 kV energized line, a technician notices that a rubber blanket has a small tear along one edge. What should the technician do? A. Fold the blanket so the tear is fully covered by an overlapping insulated layer. B. Apply electrical tape over the tear to restore the insulating value of the blanket. C. Remove the damaged blanket using hot sticks and replace it with a new tested blanket. D. Reduce the work scope to avoid any contact near the area covered by the torn blanket. The correct answer is C. Removing the damaged blanket and replacing it with a new tested blanket is the correct action. Any tear or damage to a rubber insulating blanket compromises its dielectric integrity and could allow current to arc through the defect. Damaged protective equipment must be immediately removed from service and replaced. Folding, taping, or working around the damage are unsafe practices that violate live-line work standards. Question 31. When a Powerline technician on a pole needs to communicate with the ground crew operating a crane during a pole-top operation, what is the preferred method? A. Voice communication relayed through the utility dispatch center via two-way radio. B. Pre-arranged hand signals visible to both the pole worker and the crane operator. C. Cellular phone calls placed between the pole-top worker and the crane operator. D. Written instructions passed up to the pole worker in a canvas tool hoisting bag. The correct answer is B. Pre-arranged hand signals visible to both the pole worker and crane operator are the preferred communication method during crane operations. Hand signals provide immediate, clear, and standardized communication that is not affected by noise from equipment or wind. All crew members must be trained in the standard hand signals for hoisting operations, and a designated signal person must have a clear line of sight to the crane operator at all times. Question 32. What is a key responsibility of a journeyperson Powerline technician when mentoring an apprentice on the job? A. Allowing the apprentice to work independently on energized circuits to build confidence. B. Restricting the apprentice to ground-level observation until the final year of training. C. Assigning the apprentice to complete all documentation and paperwork for the crew. D. Demonstrating safe work practices and providing constructive feedback on performance. The correct answer is D. Demonstrating safe work practices and providing constructive feedback on performance is the journeyperson's core mentoring responsibility. Effective mentoring combines hands-on demonstration with guided practice under direct supervision, gradually increasing the complexity of tasks as the apprentice develops competency. Feedback must be timely, specific, and focused on both safety practices and technical skills to build a competent and safety-conscious Powerline technician. Question 33. What species of wood is most commonly used for utility distribution poles in Western Canada? A. Sugar maple pressure treated with copper azole compound preservative. B. White spruce treated with chromate copper arsenate preservative solution. C. Western red cedar treated with pentachlorophenol or equivalent preservative. D. Southern yellow pine treated with creosote oil preservative compound. The correct answer is C. Western red cedar is the most commonly used wood species for utility distribution poles in Western Canada due to its natural decay resistance, light weight relative to strength, and straight grain. Cedar poles are typically treated with pentachlorophenol or other approved preservatives to extend their service life. Douglas fir is also widely used, particularly where higher strength is required for longer spans or heavier conductor loads. Question 34. What does the classification number stamped on a wooden utility pole indicate? A. The year of manufacture and the preservative treatment batch code number. B. The minimum circumference and load-bearing strength at 600 mm from the top. C. The geographic region where the timber was harvested and officially graded. D. The maximum conductor weight the pole can support without guy wire assistance. The correct answer is B. The classification number on a wooden utility pole indicates the minimum circumference and load-bearing strength measured at 600 mm from the top. Class 1 poles are the strongest standard class, with increasing class numbers indicating decreasing strength. For example, a Class 2 pole in a given length has a smaller top circumference and lower horizontal load capacity than a Class 1 pole of the same length. Pole class is selected based on the mechanical loading calculations for the specific installation. Question 35. When framing a three-phase distribution pole, what determines the correct spacing between conductors on the crossarm? A. The total weight of the conductors divided by the crossarm material strength rating. B. The height of the pole above ground level and the seasonal ambient temperature range. C. The operating voltage of the circuit and the required phase-to-phase clearance distance. D. The diameter of the insulator pin and the available bolt hole positions on the crossarm. The correct answer is C. The operating voltage of the circuit determines the required phase-to-phase clearance, which dictates conductor spacing on the crossarm. Higher voltages require greater separation to prevent flashover between phases under adverse conditions such as wind, ice loading, and contamination. Standard crossarm configurations specify pin positions that maintain adequate clearances for the design voltage while accommodating the mechanical loads. Question 36. What is the purpose of installing a crossarm brace on a wooden distribution pole? A. To provide a mounting surface for the pole ground wire and grounding electrode clamp. B. To prevent the crossarm from rotating or deflecting under the conductor and wind load. C. To act as a lightning shield protecting the mounted transformer from voltage surges. D. To increase the vertical clearance between the neutral conductor and the primary lines. The correct answer is B. A crossarm brace prevents the crossarm from rotating or deflecting under the mechanical load of the conductors, insulators, and environmental forces such as wind and ice. Braces are typically flat steel or angle iron installed diagonally between the crossarm and the pole, transferring the vertical and horizontal loads into the pole body. Without braces, the crossarm bolts alone would bear all the force, risking bolt failure or crossarm splitting. Question 37. When assembling hardware on a pole before setting, what is the correct method for installing a through bolt for a crossarm? A. Drill the bolt hole 3 mm larger than the bolt diameter and hand tighten the nut only. B. Drive the bolt through the existing factory drilled hole without any additional drilling. C. Use a lag screw instead of a through bolt to minimize damage to the pole wood fibers. D. Drill the bolt hole to match the bolt diameter exactly and torque the nut to specification. The correct answer is D. The bolt hole must be drilled to match the bolt diameter exactly and the nut torqued to specification to create a secure connection. An oversized hole allows movement that leads to hardware loosening and crossarm rotation. A properly sized hole distributes the load evenly around the bolt, and the correct torque ensures the assembly remains tight under dynamic loading from wind and ice. Squaring washers are used against the round pole surface to prevent the nut from pulling into the wood. Question 38. What is the standard depth for setting a 12 meters distribution pole in firm soil? A. 1/4 of the total pole length regardless of soil type or loading conditions. B. 10% of pole length plus 600 mm, giving approximately 1.8 meters for a 12 meters pole. C. A fixed 1.5 meters depth as specified by the manufacturer for all standard wood poles. D. Equal to the pole circumference at the ground line converted to a depth measurement. The correct answer is B. The standard burial depth for a 12 meters pole is approximately 1.8 meters, calculated using the industry rule of 10% of pole length plus 600 mm, 1.2 meters plus 0.6 meters equals 1.8 meters. This formula provides adequate embedment to resist overturning from conductor tension, wind, and ice. A 1/4 rule would bury 3.0 meters, which is excessive. No fixed depth applies to all pole lengths. Ground line circumference is a strength indicator, not a depth formula. Question 39. When setting a pole with a crane, what tool is used by the ground crew to guide the pole but into the hole? A. A come-along winch attached to a temporary anchor driven at ground level. B. A hydraulic jack positioned at the edge of the augered hole for leverage. C. A pike pole with a steel hook used to push and steer the suspended pole butt. D. A chain sling wrapped around the pole base and guided by hand from below. The correct answer is C. A pike pole is a long wooden or fiberglass handle with a steel hook and point on the end, used by the ground crew to push, pull, and guide the pole butt into the augered hole during crane setting. Pike poles keep workers at a safe distance from the suspended pole while providing the mechanical advantage needed to control the butt end. Multiple pike poles may be used simultaneously for large or heavy poles. Question 40. A crew is setting a pole in an area with a high water table and the augered hole keeps filling with water. What is the best approach to ensure a stable pole set? A. Set the pole in the water-filled hole and backfill with crushed gravel for drainage. B. Abandon the hole location and move the pole position at least 3 meters to higher ground. C. Drive a steel casing into the hole first and set the pole inside the permanent sleeve. D. Pump the water out immediately before setting and backfill rapidly with native soil. The correct answer is A. Setting the pole in the water-filled hole and backfilling with crushed gravel provides stable support and long-term drainage around the pole butt. Gravel backfill allows water to drain away from the pole rather than pooling, which reduces decay at the ground line. Pumping water from a high water table is temporary and ineffective because the water returns immediately. Crushed gravel compacts well even when wet and provides superior bearing capacity compared to saturated native soil. Question 41. What is the purpose of installing a strain insulator in a guy wire on a distribution pole? A. To allow the guy wire to be tensioned independently on each side of the insulator. B. To absorb vibration energy in the guy wire caused by wind-induced oscillation. C. To prevent electrical current from traveling down the guy wire to the ground anchor. D. To mark the guy wire location for visibility to nearby pedestrians and vehicles. The correct answer is C. A strain insulator in a guy wire prevents electrical current from traveling down the wire to the ground anchor. If a conductor breaks and contacts the guy wire, or if a flashover occurs at the pole top, the insulator prevents the fault current from energizing the guy wire and anchor at ground level, which would create a public safety hazard. Strain insulators are installed at a height that keeps the energized portion of the guy above public reach. Question 42. When installing a screw-type guy anchor in the ground, at what angle from the vertical should the anchor rod be driven? A. Perpendicular to the ground surface to maximize the soil-bearing capacity of the anchor. B. At 15 degrees from vertical regardless of the calculated guy wire angle to the pole. C. At 45 degrees from vertical angled toward the pole structure being supported. D. Parallel to the guy wire so the pulling force is in line with the anchor shaft axis. The correct answer is D. The anchor rod must be driven parallel to the guy wire so that the pulling force is in direct line with the anchor shaft. This alignment ensures the load is transferred axially through the anchor rod into the soil, maximizing the holding capacity of the anchor. If the anchor is not aligned with the guy wire, bending forces develop in the rod that can reduce holding capacity and lead to anchor failure under heavy loading. Question 43. What is the purpose of a guy guard installed on a guy wire near ground level? A. To increase the tensile strength of the guy wire at the anchor connection point. B. To protect pedestrians and vehicles from contact with the low-mounted guy wire. C. To provide a visual marker identifying the voltage class of the adjacent circuit. D. To prevent galvanic corrosion of the guy strand at the soil transition zone. The correct answer is B. A guy guard is a yellow or high-visibility plastic sleeve installed on the guy wire near ground level to protect pedestrians and vehicles from contact with the wire. The guard makes the guy wire visible and provides a smooth protective surface that reduces the risk of injury from contact with the steel strand. Guy guards are required on all guy wires installed in areas accessible to the public. Question 44. During a pole replacement, the crew discovers that the existing pole hole is oversized due to frost heave and previous rocking. What corrective action should be taken when setting the new pole? A. Install the new pole in the same hole and fill the gaps with expanding foam insulation. B. Set the new pole in the existing hole and tamp crushed rock backfill in 300 mm lifts. C. Wrap the pole but with a sheet of plywood to fill the gap before setting into place. D. Auger a new hole 600 mm away from the existing hole in undisturbed native soil. The correct answer is D. Augering a new hole in undisturbed soil provides the best bearing capacity and lateral resistance for the new pole. An oversized hole from frost-heave and rocking has disturbed and loosened the surrounding soil, reducing its ability to resist the overturning forces on the pole. Setting a new pole in the same enlarged hole, even with compacted backfill, will not achieve the same holding strength as undisturbed native soil. The old hole is backfilled and the new hole is positioned to maintain proper line alignment. Question 45. What type of insulator is typically used on a standard single-phase distribution pole crossarm? A. A pin-type insulator threaded onto a steel pin mounted on the crossarm surface. B. A suspension insulator string hanging below a steel davit arm bracket on the pole. C. A post-type insulator bolted directly to the top surface of the wooden crossarm. D. A strain insulator connected in series with the conductor at each dead-end point. The correct answer is A. A pin-type insulator threaded onto a steel pin mounted on the crossarm is the standard insulator used on single-phase distribution pole crossarms. The conductor sits in the groove on top of the insulator and is secured with a tie wire. Pin-type insulators are economical, easy to install, and suitable for the voltage and mechanical loads encountered on typical distribution tangent poles. Suspension and strain insulators are used for higher voltage or dead-end applications. Question 46. When assembling a steel lattice transmission tower on the ground before erection, what is critical regarding bolt installation? A. All bolts must be installed with threads facing down to shed water and prevent corrosion. B. All bolts must be torqued to engineered specification and marked to confirm tightening. C. All bolts must be welded after initial hand tightening to prevent loosening under vibration. D. All bolts must be replaced with stainless steel fasteners in coastal or humid regions. The correct answer is B. All bolts must be torqued to the engineered specification and visually marked to confirm tightening during assembly. Proper bolt torque ensures the structural integrity of each connection point, which is critical because lattice towers rely on the cumulative strength of hundreds of bolted joints. Under-torqued bolts can work loose from vibration, while over-torqued bolts can strip threads or crack members. Marking each bolt head after torquing provides a visual audit trail. Question 47. What foundation type is commonly used for steel lattice transmission towers on stable ground? A. Timber cribbing stacked to the required elevation with compacted gravel fill. B. Driven steel piles welded to a base plate at each corner of the tower structure. C. Poured reinforced concrete piers with embedded anchor bolts for each tower leg. D. Compacted gravel pads with leveling shims placed under each tower leg base plate. The correct answer is C. Poured reinforced concrete piers with embedded anchor bolts are the standard foundation for steel lattice transmission towers on stable ground. Each tower leg is bolted to a separate concrete pier, and the piers are designed to resist the uplift, compression, and shear forces transmitted through the tower under maximum loading conditions. Anchor bolt templates are set during concrete placement to ensure precise alignment with the tower base dimensions. Question 48. A steel lattice transmission tower at an angle point requires guy wires to resist the transverse load. During installation, the crew finds that the guy anchor holding capacity test result is 15% below the design requirement. What should the crew do? A. Accept the result and reduce the conductor tension at the angle point to compensate. B. Remove the anchor and install a larger capacity anchor at the same tested location. C. Install a second anchor alongside the first to share the calculated load requirement. D. Report the result to engineering and obtain an approved remediation design first. The correct answer is D. Reporting the result to engineering and obtaining an approved remediation design is required when a guy anchor test falls below the design requirement. Structural changes to a transmission tower guying system must be engineered because they affect the overall tower loading analysis. Installing a second anchor, increasing anchor size, or reducing conductor tension are all potential solutions, but each must be evaluated by a professional engineer to ensure the modified design meets the safety factors and loading requirements for the specific installation. Question 49. What type of conductor consists of aluminum strands wrapped around a steel core for increased tensile strength? A. All aluminum conductor, AAC, stranded. B. All aluminum alloy conductor, AAAC. C. Aluminum conductor steel reinforced, ACSR. D. Aluminum conductor alloy reinforced, ACAR. The correct answer is C. Aluminum conductor steel reinforced, ACSR, uses a galvanized steel core surrounded by aluminum strands, combining the conductivity of aluminum with the mechanical strength of steel. AAC contains only aluminum strands with no steel reinforcement. AAAC uses aluminum alloy strands for improved strength without steel. ACAR uses an aluminum alloy core rather than steel. Question 50. During a tension stringing operation, what equipment is positioned at the reel end to control the conductor payout speed? A. A hydraulic puller with calibrated tension gauge. B. A capstan winch with variable speed control. C. A come-along clamp with ratchet mechanism. D. A bull wheel tensioner with adjustable braking. The correct answer is D. A bull wheel tensioner positioned at the reel end applies controlled braking force to the conductor as it is paid out, maintaining adequate tension to keep the conductor off the ground and prevent damage. The hydraulic puller is positioned at the opposite end to pull the conductor. A capstan winch is used for different rigging applications. Come-along clamps are temporary gripping devices, not payout control equipment. If you're finding these questions helpful, please subscribe and hit the bell icon. It helps other apprentices find this resource too. Now let's continue. Question 51. When stringing conductor across a highway crossing, what safety measure must be in place before pulling operations begin? A. Temporary guard structures must be erected over the roadway. B. All traffic must be permanently rerouted for the duration of the project. C. Stringing must only occur between 2200 and 0500 hours. D. A single flag person at the nearest intersection is sufficient. The correct answer is A. Temporary guard structures must be erected over highway crossings to protect traffic from conductor contact during stringing operations. These structures support the conductor at a safe height above the roadway. Permanently rerouting traffic is impractical and not required. Time restrictions alone do not eliminate the hazard. A single flag person cannot prevent a falling conductor from contacting vehicles. Question 52. What is the primary factor that sag tables account for when determining the correct conductor sag at a given span? A. The ambient temperature at the time of installation. B. The color of the conductor insulation jacket. C. The number of insulators on each pole. D. The age of the pole structures in the line. The correct answer is A. Sag tables are indexed by ambient temperature because conductors expand and contract with temperature changes, directly affecting sag. Installing at the wrong temperature compensation results in excessive sag in summer or excessive tension in winter. Insulation color, insulator count, and pole age do not directly determine the required conductor sag for a given span length. Question 53. A Powerline technician is sagging ACSR conductor at 25 degrees Celsius across a 75 meters span. The sag table specifies 1.2 meters of sag. Which method uses a surveying instrument to verify the sag from the ground? A. Attaching a dynamometer to the conductor at midspan. B. Sighting the low point of the catenary with a transit instrument. C. Measuring the conductor temperature with a contact pyrometer. D. Counting the number of turns on the tensioner brake drum. The correct answer is B. A transit instrument, or theodolite, sighted from the ground allows the technician to verify the conductor's low point against reference marks on the poles, confirming the correct sag value from the sag table. A dynamometer measures tension, not sag directly. A contact pyrometer verifies temperature but does not measure sag. Brake drum turns indicate payout length, not installed sag. Question 54. A crew is sagging conductor on a line with uneven terrain where successive span lengths vary from 50 meters to 120 meters. What is the most significant risk if uniform sag values are applied to all spans? A. The conductor color may fade unevenly across the spans. B. The conductor will sag identically in every span regardless of length. C. Photocell sensors on adjacent poles may activate prematurely. D. Excessive tension in short spans may overload structures and hardware. The correct answer is D. Applying uniform sag to spans of different lengths creates unbalanced horizontal tensions at each structure. Short spans with the same sag as long spans develop excessive tension, potentially overloading poles, crossarms, and hardware beyond their rated capacity. Ruling span calculations must be used to determine appropriate sag for each span. Conductor color is unrelated. Identical sag in different span lengths produces different tensions. Photocells are not affected by conductor sag. Question 55. What instrument is attached directly to a conductor to measure the mechanical tension during sagging operations? A. A clamp-on ammeter calibrated for static loads. B. A digital inclinometer mounted on the crossarm. C. A dynamometer connected in line with the conductor. D. A laser rangefinder aimed at midspan from the pole. The correct answer is C. A dynamometer is connected in line with the conductor to provide a direct reading of the mechanical tension in kilonewtons or pounds, allowing the technician to compare against sag table tension values. A clamp-on ammeter measures electrical current, not mechanical tension. An inclinometer measures angle, not tension. A laser rangefinder measures distance, not force. Question 56. On a tangent pole with post-type insulators, which tie method is most commonly used to secure the conductor? A. A double-arming bolt through the conductor and insulator. B. A preformed top tie wrapped around the conductor and insulator neck. C. A hotline clamp bolted directly to the crossarm. D. A compression dead-end fitting crimped onto the conductor. The correct answer is B. Preformed top ties are helical rods that wrap around the conductor and the insulator neck, providing a secure hold at tangent, straight line positions without damaging the conductor surface. Double-arming bolts join crossarms, not conductors. Hotline clamps are temporary maintenance devices. Compression dead-end fittings are used at angle and terminal structures, not tangent positions. Question 57. At a dead-end structure where the conductor terminates, which hardware assembly is used to grip and anchor the conductor? A. A suspension clamp hung from a clevis and pin. B. A preformed side tie with an armor rod wrap. C. A split bolt connector with tape insulation overlay. D. A compression dead-end fitting swaged onto the conductor. The correct answer is D. A compression dead-end fitting is hydraulically swaged, crimped, onto the conductor end, creating a permanent grip capable of holding the full rated tension at terminal and heavy angle structures. Suspension clamps support conductor weight at tangent points but do not anchor. Side ties secure conductor to insulators at tangent poles. Split bolt connectors are low-voltage tap connections, not anchoring hardware. Question 58. When tying in conductor at an angle structure where the line changes direction by 15 degrees, what additional consideration is required compared to a tangent tie? A. The insulator and hardware must resist the resultant horizontal side load. B. The tie wire gauge must be doubled to handle the extra weight. C. A second conductor must be run in parallel through the angle. D. The pole height must be increased by at least 3 meters at the angle. The correct answer is A. At angle structures, the conductor tension from each side creates a resultant horizontal force that pulls the insulator and hardware toward the inside of the angle. The insulator string, hardware, and structure must be rated to resist this side load. Doubling tie wire gauge does not address the structural loading. Running a parallel conductor is unnecessary. Pole height is determined by clearance requirements, not the line angle alone. Question 59. When making a full tension compression splice on ACSR conductor, what is the correct sequence of sleeve installation? A. Compress the aluminum sleeve first, then the steel sleeve. B. Compress both sleeves simultaneously with a dual-action press. C. Compress the steel core sleeve first, then the aluminum sleeve over it. D. Install only the aluminum sleeve since the steel core does not require splicing. The correct answer is C. The steel core sleeve must be compressed first to restore the mechanical strength of the conductor, then the aluminum outer sleeve is compressed over it to restore both electrical continuity and additional mechanical support. Compressing aluminum first would prevent access to the steel core. Simultaneous compression is not possible with standard tooling. Both components must be spliced for a full tension joint. Question 60. A crew discovers a damaged section of 477 mcm ACSR conductor midspan that requires a splice. The utility standard limits the number of full tension splices per span to 1. What should the crew do if a splice already exists in the span? A. Install the second splice and document it for future monitoring. B. Apply a temporary repair sleeve and leave the conductor in service indefinitely. C. Cut out the damage and pull the remaining conductor to take up the slack. D. Replace the entire span of conductor between the two adjacent structures. The correct answer is D. When the maximum number of splices per span has been reached, the entire span of conductor must be replaced to maintain structural integrity and comply with utility standards. Each splice introduces a potential weak point, and exceeding the limit compromises safety margins. Installing a second splice violates the standard. A temporary sleeve is not a permanent solution. Cutting out conductor and pulling up slack alters the sag and tension beyond acceptable limits. Question 61. What is the purpose of applying oxide-inhibiting compound inside a compression connector before crimping it onto aluminum conductor? A. To lubricate the conductor for easier insertion into the sleeve. B. To color-code the splice for visual identification during inspections. C. To prevent aluminum oxide formation that increases electrical resistance. D. To reduce the hydraulic pressure required by the compression tool. The correct answer is C. Oxide-inhibiting compound prevents the formation of aluminum oxide at the contact surfaces inside the connector. Aluminum oxide is a poor conductor that increases resistance and causes heating at the splice point. While the compound has some lubricating properties, its primary purpose is corrosion prevention. It is not used for color coding or to reduce crimping pressure. Question 62. When pulling cable through a duct bank system, what is the primary purpose of monitoring the pulling tension with a dynamometer or load cell? A. To verify the cable weight for inventory and billing purposes following the recommended service protocol. B. To ensure the pulling tension does not exceed the cable manufacturer's maximum rated limit. C. To calculate the exact length of cable installed in the duct in accordance with standard industry practices. D. To determine the ambient soil temperature around the duct bank as per the applicable safety requirements. The correct answer is B. Monitoring pulling tension ensures the cable manufacturer's maximum sidewall bearing pressure and tension limits are not exceeded, which would damage the cable insulation or conductor. Exceeding these limits can cause immediate or latent insulation failure. Cable weight for inventory is tracked by other means. Cable length is measured from real markings, not pulling force. Soil temperature is measured with probes, not dynamometers. Question 63. What is the minimum burial depth typically required for underground power cables installed in a duct bank system under a roadway in Canadian jurisdictions? A. Deep enough to clear the frost line only, with no fixed minimum depth requirement. B. 900 mm below the road surface grade as required by electrical codes. C. At sidewalk depth of 300 mm since the duct bank provides mechanical protection. D. Below the water table level to prevent moisture damage to cable insulation. The correct answer is B. Canadian electrical codes and utility standards typically require a minimum burial depth of 900 mm for underground duct banks beneath roadways to protect against damage from traffic loading and future excavation. Frost line depth alone does not account for mechanical loading from vehicles. A shallow 300 mm depth provides no protection under vehicular traffic regardless of duct bank strength. Water table depth varies by location and is unrelated to the burial depth standard. Question 64. When installing direct buried cable, what material is placed in the trench above the cable to warn future excavators of the cable's presence? A. A layer of crushed gravel compacted to 95% density. B. A continuous concrete cap poured over the cable. C. A wooden plank laid directly on top of the cable jacket. D. Caution tape or warning tape placed 300 mm above the cable. The correct answer is D. Caution tape, also called warning tape, is buried approximately 300 mm above the cable in the trench backfill to alert anyone excavating in the area that energized cable is below. This provides an early warning before the excavation reaches the cable depth. Crushed gravel bedding supports the cable but does not warn excavators. Concrete caps are used in specific applications but are not the standard warning method. Wooden planks are not a recognized warning device. Question 65. A technician is splicing 25 kV XLPE underground cable in a manhole and notices moisture inside one cable end. What is the correct course of action? A. Proceed with the splice after wiping the conductor dry with a clean cloth. B. Cut back the cable beyond the moisture intrusion and retest insulation resistance before splicing. C. Heat the cable end with a propane torch to evaporate the trapped moisture. D. Apply additional mastic sealant around the splice body to seal out moisture. The correct answer is B. Moisture contamination in XLPE insulation causes electrical treeing that leads to premature cable failure. The affected section must be cut back to sound, dry insulation, and an insulation resistance test, MEGR, must confirm the cable is free of moisture before the splice is made. Wiping the conductor does not remove moisture absorbed into the insulation. Heating with an open flame risks damaging the cable insulation and is a fire hazard in a manhole. Mastic sealant does not remove existing moisture. Question 66. What is the primary function of a stress cone installed at a medium voltage underground cable termination? A. To provide a weatherproof seal against rain and UV exposure based on the standard operating guidelines. B. To mechanically anchor the cable to the riser pole or pad-mounted equipment. C. To gradually redistribute the electrical stress at the insulation shield cutback point. D. To increase the current carrying capacity of the cable at the terminal end. The correct answer is C. A stress cone, or stress relief cone, gradually redistributes the concentrated electrical field at the point where the cable's insulation shield is cut back, preventing voltage breakdown at that high-stress location. Without stress control, the abrupt shield termination creates an electrical stress concentration that can lead to insulation failure. Weatherproofing is a secondary function. Mechanical anchoring is done by separate hardware. Stress cones do not affect ampacity. Question 67. When installing a heat shrink termination on an underground cable transitioning to an overhead riser, what must be done to the semiconductive insulation shield before applying the termination kit? A. The shield must be scored and peeled back to the exact dimension specified by the kit manufacturer. B. The shield must be extended beyond the termination with additional conductive tape. C. The shield should be left fully intact up to the cable lug connection point. D. The shield must be coated with silicone grease along its full exposed length. The correct answer is A. The semiconductive insulation shield must be scored circumferentially and cleanly removed to the precise dimension specified by the termination kit manufacturer. An accurate cutback ensures the stress control components align correctly with the shield edge. Extending the shield beyond the termination would bypass the stress control design. Leaving the shield fully intact prevents proper termination assembly. Silicone grease is not a substitute for proper shield preparation. Question 68. When mounting a luminaire on a street light bracket arm, what must be confirmed before energizing the fixture? A. The equipment bonding conductor is connected to the pole ground. B. The bracket arm is oriented toward the nearest transformer. C. The photocell has been removed and stored for later installation. D. The fixture lens has been temporarily taped closed for transport. The correct answer is A. The equipment bonding conductor must be connected to the pole ground before energizing to provide a fault current return path and protect workers and the public from shock hazard. Bracket arm orientation is based on road layout, not transformer location. Removing the photocell would prevent automatic operation. Taping the lens has no bearing on electrical safety. Question 69. What component on a street light fixture automatically turns the light on at dusk and off at dawn? A. A thermal overload relay inside the ballast housing. B. A manual toggle switch located at the base of the pole. C. A photoelectric cell, photocell, mounted on top of the fixture. D. A programmable timer wired into the luminaire junction box. The correct answer is C. A photoelectric cell, photocell, mounted on top of the fixture detects ambient light levels and automatically switches the luminaire on at dusk when light drops below the threshold and off at dawn when light increases. Thermal overload relays protect against overcurrent, not lighting control. Manual switches would require daily human intervention. Programmable timers require manual schedule adjustment for seasonal changes. Question 70. A street light operates intermittently, cycling on and off every few minutes. Which component is the most likely cause of the cycling behavior? A. The underground feed cable has a partial insulation breakdown. B. The pole ground rod has corroded and lost its earth connection. C. The bracket arm mounting bolts have loosened from vibration. D. The photocell is failing and sending erratic on-off signals. The correct answer is D. A failing photocell commonly causes cycling behavior. It turns the light on, then the light output fools the degraded photocell into thinking it is daylight, turning the light off, and the cycle repeats. This is the most frequent cause of intermittent street light operation. A partial cable breakdown would more likely cause a sustained outage. A corroded ground rod affects fault protection, not lamp cycling. Loose mounting bolts cause physical movement, not electrical cycling. Question 71. A single-phase pole-mounted distribution transformer is rated 7,200 over 14,400 V primary and 120 over 240 V secondary. What does the dual primary voltage rating indicate? A. The transformer requires two separate primary fuses of different ratings. B. The primary winding has two sections that can be connected in series or parallel. C. The transformer can supply two different secondary voltages simultaneously. D. The transformer operates at 7,200 V in summer and 14,400 V in winter. The correct answer is B. The dual primary voltage rating indicates the transformer has two primary winding sections that can be connected in parallel for 7,200 V service or in series for 14,400 V service, allowing the same transformer to be used on either voltage system. The secondary voltage remains 120 over 240 V regardless of primary connection. Two separate fuses are not required for dual voltage. Seasonal voltage changes are not a design feature of distribution transformers. Question 72. When connecting three single-phase transformers in a Y-delta bank to serve a three-phase load, which connection is made on the primary side in a grounded Y configuration? A. One end of each primary winding is connected to a common grounded neutral point. B. Each primary winding is connected across two-phase conductors with no neutral. C. The primary windings are connected in an open configuration using only two transformers. D. All three primary windings are connected in series end-to-end. The correct answer is A. In a grounded Y primary configuration, one end of each primary winding is connected to a common neutral point that is solidly grounded. The other end of each winding connects to one of the three-phase conductors. This provides a neutral reference and limits overvoltage during fault conditions. Connecting across two phases without neutral describes a delta configuration. An open configuration uses only two transformers for open delta service. Series connection is not a standard three-phase bank configuration. Question 73. A three-phase customer reports low voltage on one phase. Voltage readings at the transformer bank show 240 V on two phases and 190 V on the third. What is the most likely cause? A. The primary fuses on all three phases have partially blown. B. The customer's main breaker is oversized for the service panel. C. An oversized secondary neutral conductor is creating voltage imbalance. D. One transformer in the bank has an internal winding fault reducing its output. The correct answer is D. Low voltage on one phase with normal voltage on the other two phases indicates a problem isolated to one transformer in the bank. An internal winding fault such as shorted turns reduces the transformer's output voltage while the other two remain unaffected. Primary fuses do not partially blow, they either conduct or interrupt. An oversized main breaker would not cause voltage drop on one phase. An oversized neutral would have lower resistance, improving voltage balance rather than causing imbalance. Question 74. What is the primary purpose of installing capacitor banks on a distribution feeder? A. To increase the frequency of the alternating current on the feeder. B. To store energy for backup power during momentary outages. C. To correct power factor by supplying reactive power to inductive loads. D. To convert single-phase power to three-phase power for large customers. The correct answer is C. Capacitor banks supply leading reactive power, VARs, to offset the lagging reactive power drawn by inductive loads such as motors, improving the power factor of the feeder. This reduces current flow, lowers losses, and improves voltage profiles. Capacitors do not change system frequency. While capacitors store small amounts of energy, they are not intended for outage backup. Phase conversion requires specialized equipment, not capacitors. Question 75. Before handling a pole-mounted capacitor unit that has been disconnected from the line, what safety step must be performed? A. The unit must be wrapped in insulating blankets to prevent static discharge according to the equipment specifications. B. The unit must be allowed to discharge through its internal resistors for at least 5 minutes, then manually short-circuited and grounded. C. The unit label must be photographed for warranty documentation purposes following the site-specific work procedures. D. The unit must be rotated upside down to drain the dielectric fluid completely before any handling. The correct answer is B. Capacitors retain a potentially lethal charge after disconnection. Internal discharge resistors reduce the voltage over several minutes, but a manual short circuit and grounding with a grounding device is required before handling to ensure the capacitor is fully discharged. Insulating blankets do not discharge stored energy. Photographing the label is for record keeping, not safety. Rotating the unit does not discharge stored energy. Question 76. A step-type voltage regulator on a distribution feeder is set with a bandwidth of plus or minus 1.5 V on a 120 V base. What does this bandwidth setting control? A. The voltage dead band within which the regulator will not initiate a tap change. B. The number of tap positions available on the regulator winding. C. The time delay before the regulator responds to a voltage deviation. D. The maximum voltage the regulator can boost above nominal. The correct answer is A. The bandwidth setting defines a dead band, in this case 120V plus or minus 1.5V, or 118.5V to 121.5V, within which the regulator does not initiate a tap change. This prevents excessive tap operations due to minor voltage fluctuations. The number of tap positions is a fixed design parameter of the regulator. Time delay is a separate adjustable setting. The maximum boost is determined by the regulator's total tap range, not bandwidth. Question 77. When operating a gang-operated air brake switch to de-energize a section of line, what is the correct procedure for a three-phase switch? A. Open each phase individually starting with the phase closest to the operator. B. Close the grounding blade first, then open the main switch blades. C. Open the center phase first, then the two outer phases one at a time. D. Open all three phases simultaneously using the gang operating mechanism. The correct answer is D. Gang-operated switches are designed to open all three phases simultaneously through a single operating mechanism, ensuring balanced interruption and preventing single-phasing of connected equipment. Opening phases individually on a gang switch defeats its design purpose and can damage three-phase equipment. The grounding blade must only be closed after the main blades are open and the circuit is confirmed de-energized. Center phase first sequencing applies to specific live-line procedures, not standard gang switch operation. Question 78. What distinguishes a load break switch from a disconnect switch on a distribution system? A. A disconnect switch uses SF6 gas for arcade suppression during operation as outlined in the maintenance work order. B. A load break switch can only be operated under no-load conditions, following established workplace procedures. C. A load break switch can interrupt load current, while a disconnect provides only visible isolation. D. A disconnect switch is rated for higher voltage than a load break switch on the system. The correct answer is C. A load break switch is equipped with arc interrupting features, such as whips or arc chutes, that allow it to safely interrupt normal load current, while a disconnect switch provides only visible isolation and must be operated under no load or de-energized conditions. Disconnect switches do not use SF6 gas. That technology is used in enclosed switchgear. Load break switches are specifically designed for load interruption, not limited to no load. Disconnect switches are not necessarily rated for higher voltage. Question 79. What is the primary purpose of installing a current-limiting reactor on a distribution system? A. To boost voltage on long rural feeders during peak demand periods as outlined in the job safety analysis. B. To limit the available fault current to within the interrupting rating of downstream equipment. C. To convert alternating current to direct current for battery charging stations. D. To filter harmonic frequencies generated by nonlinear loads as specified in the manufacturer documentation. The correct answer is B. Current-limiting reactors introduce impedance into the circuit to reduce the prospective fault current magnitude, keeping it within the interrupting capability of downstream protective devices such as fuses, reclosers, and breakers. Voltage boosting is performed by regulators and capacitors. AC to DC conversion requires rectifiers. Harmonic filtering uses tuned filter banks, not current-limiting reactors. Question 80. A hydraulic recloser is programmed for a 2A, 2C sequence. What does this sequence mean in terms of its fault response? A. It performs 2 fast trips followed by 2 delayed trips before locking out. B. It alternates between 2 automatic and 2 manual closing operations. C. It opens the A phase twice and the C phase twice during a fault. D. It attempts 2 reclosures on alternating phases then switches to bypass mode. The correct answer is A. A 2A, 2C, 2 fast, 2 delayed sequence means the recloser performs 2 fast, instantaneous, trip operations to clear temporary faults, followed by 2 time delayed, curve, trips that allow fuses to blow for permanent faults, before locking out if the fault persists. The A designation refers to the fast curve and C to the delayed curve. It does not refer to specific phases or manual versus automatic operations. Question 81. After a recloser locks out on a distribution feeder, a technician is dispatched to investigate. The recloser has non-reclosing block engaged. What must the technician verify before resetting the recloser to automatic operation? A. That the recloser oil level is at the maximum fill line according to standard operating procedures. B. That all downstream customers have been individually notified of the restoration. C. That the fault has been located and cleared, or the line has been patrolled and found clear. D. That the upstream substation breaker has been upgraded to a higher rating. The correct answer is C. Before resetting a locked-out recloser to automatic operation, the technician must confirm that the cause of the lockout has been identified and cleared, or the entire protected line section has been patrolled and found free of hazards. Re-energizing onto a sustained fault creates safety hazards and equipment damage. Oil level is a maintenance item, not a prerequisite for reset. Individual customer notification is not required before re-energization. Upstream breaker upgrades are unrelated to the immediate fault. Question 82. How does a sectionalizer determine when to open and isolate a faulted line section? A. It monitors conductor temperature and opens when thermal limits are exceeded following the recommended service protocol. B. It measures the voltage drop across the line and opens when voltage falls below a preset threshold value. C. It receives a direct signal from the substation SCADA system commanding it to open immediately. D. It counts the number of times the upstream recloser or breaker interrupts fault current, then opens during a de-energized interval. The correct answer is D. A sectionalizer counts the number of fault current interruptions made by the upstream backup device, recloser or breaker. After a preset count is reached, the sectionalizer opens during the next de-energized interval to isolate the faulted section, allowing the upstream device to reclose successfully on the healthy portion of the feeder. It does not independently measure voltage, conductor temperature, or receive SCADA commands for its primary protective function. Question 83. A sectionalizer is set to open after 2 counts and is coordinated with an upstream recloser on a 2A, 2C sequence. During a permanent fault downstream of the sectionalizer, at what point in the sequence should the sectionalizer isolate the faulted section? A. Immediately upon detection of fault current without waiting for any recloser operations. B. After the second fast trip of the recloser, during the open interval before the first delayed trip. C. After the recloser has completed all 4 operations and locked out based on the standard operating guidelines. D. After the first fast trip of the recloser, before any reclose attempt according to the equipment specifications. The correct answer is B. With a count of 2, the sectionalizer registers each time the upstream recloser trips and de-energizes the line. After the second fast trip, 2A operations, the sectionalizer opens during the dead interval before the recloser attempts its first delayed, C-curve, reclose. This isolates the faulted section so the recloser recloses onto the healthy portion of the feeder. Immediate opening without counts is not how sectionalizers operate. Waiting for lockout defeats the purpose of the sectionalizer. Opening after only 1 count is premature. Question 84. What type of distribution fuse uses a spring-loaded ejection mechanism to provide a visible indication that the fuse has operated? A. An expulsion fuse with a dropout fuse cutout. B. A solid-state electronic fuse with LED indicator. C. An open-link fuse mounted on a porcelain insulator. D. A current-limiting fuse with sand-filled housing. The correct answer is A. An expulsion fuse housed in a dropout fuse cutout uses a spring-loaded hinge mechanism that causes the fuse tube to drop open when the fusible element melts, providing a clear visible indication from the ground that the fuse has operated. Solid-state electronic fuses are not standard pole-mounted distribution equipment. Open-link fuses are older technology without dropout indication. Current-limiting fuses do not have a dropout mechanism. Question 85. When coordinating fuses on a distribution system, what principle ensures that the fuse closest to the fault operates first? A. Both fuses must be identical in rating so they share the fault current equally. B. The upstream fuse must have a higher continuous current rating with a faster time current curve. C. The upstream fuse must be a current limiting type while the downstream fuse is an expulsion type. D. The downstream fuse must clear the fault before the upstream fuse reaches its minimum melting time. The correct answer is D. Proper fuse coordination requires that the downstream, closer to fault, fuse total clearing time is less than the upstream, source side, fuse minimum melting time at all fault current levels within the coordination range. This ensures the downstream fuse clears the fault while the upstream fuse remains intact, limiting the outage to the smallest possible section. Identical fuses would not coordinate. A faster upstream curve would cause the upstream fuse to blow first. Fuse type alone does not determine coordination. Question 86. What is the operating principle of a metal oxide varistor, MOV, lightning arrestor used on distribution systems? A. It stores surge energy in a capacitor bank and releases it slowly after the surge passes. B. It diverts surge current through a fuse element that sacrificially melts to protect equipment. C. It uses a nonlinear resistance element that conducts heavily at high voltage and blocks at normal voltage. D. It creates an air gap that arcs over at a preset voltage to shunt surge energy to ground. The correct answer is C. Metal oxide varistor, MOV, arrestors use zinc oxide elements with a nonlinear voltage current characteristic. At normal system voltage the resistance is extremely high, essentially non-conducting, but at surge voltages the resistance drops dramatically, diverting surge current to ground. After the surge, the element returns to high resistance. Storing energy in capacitors is not the MOV operating principle. MOV arrestors are not sacrificial fuse devices. Air gap arrestors are older gapped technology. Question 87. When installing a distribution lightning arrestor on a pole-mounted transformer, where must the arrestor ground lead be connected? A. To an isolated ground rod dedicated solely to the arrestor under standard operating conditions. B. To the transformer tank ground, equipment ground, and system neutral with the shortest possible lead length. C. To a separate copper bus bar mounted 2 meters below the transformer on the pole. D. To the primary conductor neutral only, with no connection to the transformer tank. The correct answer is B. The arrestor ground lead must be connected to the transformer tank ground, equipment ground, and system neutral using the shortest possible lead length to minimize the impedance of the ground path. High impedance in the ground connection reduces the arrestor's effectiveness by allowing higher voltages to appear at the protected equipment. An isolated ground rod creates a potential difference. A separate bus bar 2 meters away adds unnecessary lead length and impedance. Connecting only to the neutral excludes the tank ground. Question 88. When installing current transformers, CTs, for primary metering on a 25 kV distribution line, what safety precaution is critical regarding the CT secondary winding? A. The secondary winding must never be open-circuited while the primary is energized. B. The secondary winding polarity markings can be ignored for metering applications. C. The secondary winding must be left open-circuited to prevent overcurrent. D. The secondary winding must be connected directly to the station battery for backup power. The correct answer is A. A CT secondary winding must never be open-circuited while the primary conductor carries current. An open secondary forces all the magnetic flux through the core unimpeded, generating dangerously high voltages across the secondary terminals, potentially thousands of volts, and overheating the core. The secondary must always be shorted or connected to its burden. Ignoring polarity markings causes metering errors. Connecting to a battery is incorrect and dangerous. Leaving the secondary open is the exact hazard to avoid. Question 89. A primary metering installation uses CTs with a ratio of 200:5 and PTs with a ratio of 14400:120. The meter reads 45 kWh over a billing period. What is the actual energy consumption at the primary level? A. 2160 kWh after applying only the CT multiplier. B. 5,400 kilowatt-hours after applying the PT multiplier alone. C. 45 kilowatt-hours because the meter is already calibrated for primary values. D. 216,000 kilowatt-hours after applying both CT and PT multipliers. The correct answer is D. The combined instrument transformer multiplier is the CT ratio times the PT ratio, 200/5, multiplied by 14,400 over 120, equals 40 multiplied by 120, which equals 4,800. The actual primary energy consumption is 45 kilowatt-hours multiplied by 4,800, which equals 216,000 kilowatt-hours. Applying only the CT multiplier gives an incomplete result. Applying only the PT multiplier is also incomplete. Standard metering CTs and PTs step values down, so the meter reading must be multiplied up. Question 90. When installing a self-contained 200A meter base on a residential service, what determines the correct position of the meter socket on the building? A. The homeowner's preferred location for aesthetic reasons following the site-specific work procedures. B. The side of the building that receives the least amount of direct sunlight. C. The utility specifications for height, accessibility, and proximity to the service entrance. D. The location of the nearest interior electrical panel regardless of exterior access. The correct answer is C. The meter socket position must comply with the utility specifications for mounting height, typically 1.5 meters to 1.8 meters center, accessibility for meter reading and maintenance, and proximity to the service entrance mast or underground lateral. These requirements ensure safe and efficient access for utility personnel. Homeowner aesthetics, sun exposure, and interior panel location are not the determining factors for meter placement. Question 91. What is the purpose of the test block, test switch, installed in a metering cabinet for a commercial three-phase service? A. To switch between peak and off-peak billing rates automatically. B. To allow the meter to be tested or replaced without disconnecting the customer's service. C. To provide a ground fault protection point for the metering circuit. D. To enable the customer to read their own meter remotely via wireless connection. The correct answer is B. The test block allows the meter to be tested or replaced without disconnecting the customer's service, because it provides a safe means to isolate the metering circuits while maintaining power flow to the customer. During meter removal, built-in short-circuiting links maintain CT secondary continuity to prevent dangerous open-circuit voltages. Test blocks do not control billing rates, provide ground fault protection, or enable remote meter reading. Question 92. When installing cellular antenna equipment on a utility distribution pole, what is the primary concern regarding the placement of the antenna relative to the power conductors? A. Adequate vertical separation must be maintained between the antenna and power conductors as specified by electrical code. B. The antenna feed cable must be run along the same arm as the power conductors for support. C. The antenna must be mounted above the primary conductors for better signal reception. D. The antenna must be oriented to face the nearest power conductor for electromagnetic shielding. The correct answer is A. Adequate vertical separation between cellular antenna equipment and power conductors must be maintained as specified by the Canadian Electrical Code and utility joint use agreements to prevent electrical contact, induction hazards, and to maintain safe working clearances for line workers. Antennas are mounted in the communication space below power conductors, not above them. Feed cables must be separated from power conductors. Antenna orientation is based on coverage requirements, not conductor proximity. Question 93. During a pole replacement, a technician must transfer communication cables from the old pole to the new pole. The communication company is unavailable. What is the correct approach? A. Remove the communication cables entirely and notify the communication company after the work is complete. B. Transfer the communication cables using insulated gloves rated for the primary voltage on the pole. C. Cut and resplice each communication cable to fit the new pole spacing as per the applicable industry standards. D. Leave communication cables on the old pole and complete the power transfer only, tagging the incomplete work for follow-up. The correct answer is D. When the communication company is unavailable, the technician should complete the power transfer and leave communication cables on the old pole, tagging the work as incomplete. Communication cables are the property of the communication provider. Removing or transferring them without authorization violates joint use agreements and risks service disruption and liability. Question 94. What document provides the step-by-step instructions for isolating a section of transmission line for maintenance work? A switching order issued by the System Control Center. B. The manufacturer's transformer installation guide. C. The pole inspection report from the previous maintenance cycle. D. The apprentice logbook signed by the supervising journey person. The correct answer is A. A switching order issued by the System Control Center provides the specific step-by-step sequence for isolating, tagging, testing, and grounding a transmission line section before work begins. Each step must be executed and confirmed in the prescribed order. Manufacturer guides cover equipment installation, not system switching. Inspection reports document past conditions. Apprentice logbooks record training, not operational procedures. Question 95. After opening disconnect switches to isolate a transmission line section, what must be done before applying personal protective grounds? A. The line must be visually inspected for bird nests and debris from a helicopter. B. The line must be tested for the absence of voltage at the work location using an approved voltage detector. C. The switching order must be filed with the Provincial Safety Authority as outlined in the maintenance work order. D. All vehicles in the area must be moved at least 30 meters from the base of the nearest structure. The correct answer is B. After opening disconnect switches, the line must be tested for absence of voltage using an approved high-voltage detector at the work location before applying personal protective grounds. This confirms the line is truly de-energized and accounts for potential backfeed, induced voltage, or switching errors. Visual inspection from a helicopter does not verify electrical status. Filing the switching order is administrative, not a field safety step. Vehicle positioning, while important, does not verify zero energy. Question 96. When restoring a transmission line to service after maintenance, in what order are protective grounds and isolation devices handled? A. Close the disconnect switches first, then remove the protective grounds under load. B. Remove grounds and close switches simultaneously to minimize outage time, following established workplace procedures. C. Remove all protective grounds first, then close disconnect switches as directed by the switching order. D. Leave the grounds in place permanently as additional system grounding as outlined in the job safety analysis. The correct answer is C. All personal protective grounds must be removed before closing disconnect switches to re-energize the line. Closing switches onto grounded conductors creates a short circuit that damages equipment, trips protective devices, and endangers personnel. The switching order specifies the exact sequence for ground removal and switch closure. Simultaneous operations violate safe switching procedures. Leaving grounds in place would create an intentional fault when the line is energized. Question 97. What is the primary purpose of a SCADA system in distribution network operations? A. To provide insulation testing of individual conductors under standard operating conditions. B. To calculate payroll hours for field crews as determined by the initial assessment. C. To generate engineering drawings of pole placements based on manufacturer recommendations. D. To allow remote monitoring and control of switching devices from a central location. The correct answer is D. A supervisory control and data acquisition (SCADA) system enables operators at a central control center to remotely monitor system conditions and control switching devices such as reclosers, sectionalizers, and motorized switches across the distribution network. Insulation testing is a field activity performed with specialized test equipment. Payroll calculations are an administrative function. Engineering drawings are produced by design departments, not SCADA. Question 98. When operating a load brake elbow on an energized underground distribution system, what personal protective equipment must be worn? A. A hard hat and steel-toed boots only before consulting equipment documentation. B. Leather work gloves and a reflective vest without reviewing manufacturer specifications. C. Rubber insulating gloves with leather protectors and an arc-rated face shield. D. A full body harness connected to a fall arrest system as specified in the manufacturer documentation. The correct answer is C. Operating a load brake elbow on an energized underground distribution system requires rubber insulating gloves with leather protectors rated for the system voltage plus an arc-rated face shield to protect against potential arc flash during switching. A hard hat and boots alone provide no electrical or arc protection. Leather work gloves are not electrically rated. A full body harness addresses fall hazards, not electrical switching hazards at ground-level pad-mounted equipment. Question 99. During a station switching procedure, what action must be taken immediately after opening a circuit breaker? A. Confirm the breaker is in the open position and report back to the control center operator. B. Proceed to the next step in the switching order without waiting according to standard operating procedures. C. Apply protective grounds to the bus section following the recommended service protocol. D. Begin maintenance work on the associated transformer as outlined in the maintenance work order. The correct answer is A. After opening a circuit breaker during station switching, the technician must visually confirm the breaker is in the fully open position and immediately report the completed step back to the control center operator. Each switching step requires confirmation before the next step is authorized. Proceeding without confirmation violates the sequential verification protocol. Applying grounds follows later steps in the isolation sequence. Maintenance cannot begin until full isolation, tagging, testing, and grounding are complete. Question 100. A switching order requires opening disconnect switch DS3 but the operator finds the mechanism is seized and will not move. What is the correct course of action? A. Use a longer operating handle to apply more force until the switch opens following the recommended service protocol. B. Skip DS3 and continue with the next step in the switching order in accordance with standard industry practices. C. Apply penetrating oil to the mechanism and wait 30 minutes before retrying the operation. D. Stop the switching sequence, report the condition to the control center, and await revised instructions. The correct answer is D. When a switching device cannot be operated as directed in the switching order, the technician must stop the sequence immediately and report the condition to the control center. The control center will assess the situation and either issue a revised switching order with an alternate isolation path or dispatch additional resources. Applying excessive force risks mechanical failure or uncontrolled operation. Skipping steps violates the isolation sequence integrity. Unauthorized field repairs on energized switching equipment create extreme hazards. If you're finding these questions helpful, please subscribe and hit the bell icon. It helps other apprentices find this resource too. Now let's continue. Question 101. What is the purpose of tagging a disconnect switch after it has been opened during an isolation procedure? A. To indicate the switch requires lubrication at the next maintenance interval as per the applicable safety requirements. B. To communicate to all personnel that the switch must not be operated until the tag is removed by the authorized holder. C. To record the date the switch was last inspected following the recommended service protocol. D. To mark the switch for replacement during the next capital upgrade project based on the standard operating guidelines. The correct answer is B. A tag placed on an open disconnect switch communicates to all personnel that the device must not be operated until the tag is removed by the authorized holder. This lockout-tag-out procedure prevents accidental re-energization of isolated equipment while workers are in contact with it. Tags are not maintenance scheduling tools, inspection records, or replacement markers. Question 102. During a line patrol, a technician observes a wooden pole with extensive shell rot at the ground line where less than 50% of the original cross-section remains sound. What is the appropriate classification and action? A. Classify the pole as priority replacement and report it immediately for scheduled changeout. B. Mark the pole for monitoring at the next scheduled patrol cycle according to the equipment specifications. C. Apply a preservative wrap to stop further decay and return the pole to normal service. D. Reinforce the pole with a temporary brace and continue the patrol following the site-specific work procedures. The correct answer is A. A pole with less than 50% sound wood remaining at the ground line has lost critical structural strength and is classified as a priority replacement. It must be reported immediately for scheduled changeout to prevent an uncontrolled failure that could drop energized conductors. Waiting until the next patrol cycle risks structural failure during wind or ice loading. Preservative wraps slow decay but do not restore lost structural capacity. Temporary bracing is not a substitute for replacement of a severely deteriorated pole. Question 103. What tool is used during a pole inspection to determine the internal condition of a wooden pole at the ground line? A. A torque wrench calibrated for through-bolt tension as per the applicable industry standards. B. A digital multimeter set to resistance mode without reviewing manufacturer specifications. C. A sounding hammer or resistograph drill used to assess internal decay. D. A laser rangefinder aimed at the pole top without considering system requirements. The correct answer is C. A sounding hammer is used to detect hollow sections indicating internal decay, while a resistograph drill measures wood density by recording resistance as a thin probe penetrates the pole. Both methods reveal internal rot that is not visible from the surface. A torque wrench measures bolt tension, not wood condition. A multimeter measures electrical properties, not structural integrity. A rangefinder measures distance, not internal wood soundness. Question 104. When stub setting a replacement pole alongside a deteriorated pole, what is the first step after the new pole is set in the ground? A. Transfer all hardware, crossarms, and conductors from the old pole to the new pole. B. Remove the old pole with a crane before attaching any hardware as outlined in the maintenance work order. C. Cut the old pole at the ground line and leave the butt in the hole, following established workplace procedures. D. Install through bolts to mechanically connect the new stub pole to the existing pole above the ground line. The correct answer is A. Stub setting involves setting a shorter replacement pole in the ground alongside the deteriorated pole. The first step after the new pole is set is to transfer all hardware, crossarms, and conductors from the old pole to the new pole. Once the load is transferred, the old pole can be safely removed. Removing the old pole first would leave conductors unsupported. Cutting the old pole without transferring hardware first leaves equipment stranded. Through bolting is used for pole reinforcement, not stub setting procedures. Question 105. What is the primary method used to detect internal decay in wooden distribution poles during routine maintenance inspections? A. Measure the pole circumference at ground line and compare to original specifications. B. Sound the pole with a hammer and listen for hollow areas indicating internal rot. C. Visually inspect the pole surface for discoloration or paint peeling patterns. D. Check the pole tag data and compare against the expected service life. The correct answer is B. Sounding test, hammer test, is the primary field method for detecting internal pole decay. A solid pole produces a clear ring, while a decayed pole sounds hollow or dull. This quick, non-destructive test identifies poles requiring further investigation with bore testing. Circumference measurement can indicate external loss but misses internal voids. Visual inspection detects surface issues but not internal rot. Pole tag data indicates age but not actual condition. Question 106. When inspecting a steel lattice transmission tower, what condition on the structural members indicates corrosion has progressed to a point requiring immediate repair? A. Light surface oxidation with no visible section loss on galvanized members. B. Visible section loss with flaking or pitting that reduces the original member thickness. C. Minor paint discoloration on the lower leg members near ground level. D. Bird droppings accumulated on the horizontal bracing members. The correct answer is B. Visible section loss with flaking or pitting that reduces the original member thickness indicates corrosion has progressed beyond surface oxidation and requires immediate repair to restore structural integrity. Section loss reduces the load carrying capacity of the member. Light surface oxidation on galvanized steel is normal weathering. Minor paint discoloration is cosmetic. Bird droppings, while corrosive over time, are a maintenance cleaning issue rather than an indication of immediate structural repair need. Question 107. A porcelain insulator on a 25 kV distribution line shows a hairline crack extending from the pinhole to the outer skirt. Should this insulator remain in service? A. Yes, if the crack is less than 50 mm long, it is within acceptable limits as specified in the manufacturer documentation. B. Yes, as long as the insulator is not leaking oil as specified in the manufacturer's service manual. C. No, it should be monitored monthly and replaced at the next regularly scheduled maintenance window. D. No, any crack that extends from the pinhole to the outer skirt compromises the insulating path and requires immediate replacement. The correct answer is D. Any crack that extends from the pinhole to the outer skirt of a porcelain insulator compromises the electrical creepage and strike distance, creating a path for tracking and flashover. This insulator must be replaced immediately as it can fail under wet conditions, surge events, or contamination. There is no acceptable crack length for this failure mode. Porcelain insulators are not oil-filled. Monthly monitoring risks an in-service flashover that could cause an outage or equipment damage. Question 108. When replacing a hot line clamp on an energized conductor using live line tools, what must be verified before removing the existing clamp? A. The new clamp is pre-installed and carrying the full electrical load before the old clamp is disconnected. B. The ambient temperature is above 0 degrees Celsius without reviewing manufacturer specifications. C. The wind speed is below 10 km per hour regardless of equipment operating conditions. D. The conductor has been detensioned by loosening the dead-end hardware without considering system requirements. The correct answer is A. Before removing a hot line clamp on an energized line, a temporary bypass or the new clamp must be installed and carrying the full electrical load to maintain circuit continuity. Removing the existing clamp without a bypass would create an open circuit, interrupting service and creating a dangerous arc. Temperature and wind speed are considered in the job hazard assessment but are not the verification step before clamp removal. Detensioning the conductor is not performed for a clamp replacement on an energized line. Question 109. When trimming trees near energized distribution lines, what is the minimum approach distance that must be maintained between the worker and a 25 kV conductor? A. 300 mm for all voltage levels in accordance with standard industry practices. B. 1.0 meters minimum approach distance for qualified Powerline technicians. C. 3.0 meters minimum approach distance for voltages above 750 V. D. No minimum distance is required if the worker is wearing rubber gloves. The correct answer is C. Provincial regulations typically require a minimum approach distance of 3.0 meters for uninsulated workers near conductors energized above 750 V, which includes 25 kV distribution lines. This distance accounts for potential conductor movement, tool reach, and voltage-dependent electrical clearance requirements. A distance of 300 mm is far too close for any medium-voltage conductor. The 1.0 meters distance may apply at lower voltages with specific qualifications. Rubber gloves alone do not eliminate the approach distance requirement for tree trimming activities. Question 110. What is the primary reason for directional pruning when trimming trees near power lines? A. To reduce the total volume of wood chips produced during the operation. B. To increase the aesthetic appearance of the tree for the property owner. C. To direct regrowth away from the conductors, extending the interval before the next trim is required. D. To ensure all branches fall toward the base of the pole for easy collection. The correct answer is C. Directional pruning removes branches at natural branch unions to redirect future growth away from the power line conductors. This extends the interval between trimming cycles and reduces ongoing vegetation management costs. While aesthetics and debris management are secondary considerations, the primary purpose is to establish a growth pattern that maintains safe clearance from conductors for as long as possible. Reducing wood chip volume is a byproduct, not a goal. Question 111. During overhead distribution fault patrol, what visual indicator most reliably identifies the location of a fault on the line? A. A burned or damaged fuse cutout with the fuse element melted open. B. A slightly tilted pole that has shifted from its original alignment. C. Green vegetation growing at the base of a pole as per the applicable safety requirements. D. A bird nest built on top of a crossarm based on the standard operating guidelines. The correct answer is A. A burned or damaged fuse cutout with a melted fuse element is the most reliable visual indicator of a fault location on an overhead distribution line. The fuse operates to clear the fault, and the resulting arc damage is clearly visible during patrol. A tilted pole may indicate ground movement but not necessarily an electrical fault. Vegetation at the pole base is normal. Bird nests on crossarms may cause future faults but do not indicate a current fault condition. Question 112. A recloser on a 25 kV distribution feeder has locked out after completing its programmed shot sequence. Field patrol finds no visible damage on the main trunk line. What is the most likely location of the fault? A. At the substation transformer secondary bushings according to the equipment specifications. B. On the recloser mechanism itself due to an internal mechanical failure. C. Inside the recloser control cabinet due to an internal wiring error. D. On a lateral tap downstream of the recloser where a fuse failed to coordinate. The correct answer is D. When a recloser locks out but no fault is found on the main trunk line, the most likely location is on a lateral tap where a fuse failed to coordinate with the recloser. The fault current on the lateral was high enough to trigger the recloser but not high enough to blow the lateral fuse before the recloser exhausted its shot sequence. Substation transformer bushings are upstream of the recloser and would be cleared by station protection. Recloser mechanism failures typically prevent operation rather than causing lockout. Control cabinet wiring does not create line faults. Question 113. What instrument is used to locate a fault in an underground distribution cable by measuring the time for a pulse to travel to the fault and reflect back? A. An oscilloscope connected directly to the conductor. B. A time domain reflectometer connected to the cable under test. C. A phase rotation meter following the site-specific work procedures. D. A power factor correction capacitor bank installed at the substation. The correct answer is B. A time domain reflectometer, TDR, sends an electrical pulse down the cable and measures the time for the pulse to reach an impedance change, such as a fault, and reflect back. Using the known propagation velocity of the cable, the TDR calculates the distance to the fault. An oscilloscope displays waveforms but does not send test pulses. A phase rotation meter verifies phase sequence. A capacitor bank corrects power factor and is not a test instrument. Question 114. When using a thumper to locate a faulted underground cable, what safety precaution is essential before each discharge? A. Verify that all personnel are clear of the cable route and that the area around each access point is secured. B. Confirm that the cable is energized at normal operating voltage as outlined in the job safety analysis. C. Remove all ground connections from the cable under test, as specified in the workplace safety plan. D. Ensure the thumper output is set to maximum voltage regardless of cable rating. The correct answer is A. Before each thumper discharge, all personnel must be verified clear of the cable route and every access point, manholes, handholds, pad-mounted equipment, must be secured. The thumper applies high-voltage pulses that can produce dangerous voltages at fault locations and cable terminations. The cable must be de-energized and isolated, not energized. Safety grounds remain in place at the work end. The thumper voltage must be appropriate for the cable insulation rating to avoid creating additional damage. Question 115. When splicing a damaged section of overhead distribution conductor, what type of splice is typically used for a full tension repair on ACSR conductor? A. A twist-on wire connector rated for the conductor size under standard operating conditions. B. A soldered lap joint wrapped with electrical tape as determined by the initial assessment. C. A full tension compression splice using a hydraulic press and die set matched to the conductor size. D. A bolted parallel groove clamp tightened to the manufacturer's torque specification. The correct answer is C. A full tension compression splice using a hydraulic press and matched die set restores both the electrical conductivity and the mechanical strength of the original ACSR conductor. The splice is compressed in a specific sequence, steel core first then aluminum, to achieve rated tensile strength. Twist-on connectors are for low-voltage building wiring. Soldered joints do not withstand conductor tension. Bolted parallel groove clamps are used for taps and jumpers, not full-tension line splices. Question 116. When replacing a broken crossarm on a distribution pole, what temporary support must be in place before removing the damaged crossarm? A. No support is needed if the crossarm replacement work is done quickly under standard operating conditions. B. A temporary crossarm brace or conductor support must be installed to carry the conductor load before the damaged crossarm is removed. C. The conductor should be cut and allowed to hang freely while the damaged crossarm is swapped out. D. A second crew at the next pole can hold tension on the conductors manually, following established workplace procedures. The correct answer is B. Before removing a damaged crossarm, a temporary crossarm brace or conductor support must be installed to carry the weight and tension of the conductors. Removing the crossarm without temporary support allows the conductors to fall, creating contact hazards and potentially snapping under uncontrolled loading. Working quickly is not a substitute for proper rigging. Cutting conductors creates an outage and additional repair work. Manual tension holding is unsafe and impractical. Question 117. After completing a conductor splice repair on a de-energized overhead distribution line, what must be done before requesting the line be re-energized? A. Paint the splice fitting with reflective paint for future identification under standard operating conditions. B. Take a photograph of the repair for the technician's personal records as determined by the initial assessment. C. Wait a minimum of 1 hour for the compression splice to cool based on manufacturer recommendations. D. Remove all personal protective grounds, tools, and temporary equipment from the work area and confirm clearance with the control center. The correct answer is D. Before requesting re-energization, all personal protective grounds must be removed, all tools and temporary equipment must be cleared from the work area, and clearance must be confirmed with the control center. Leaving grounds in place when the line is re-energized creates a short circuit. Painting and photography are not prerequisites for re-energization. A cooling period is unnecessary for a compression splice at ambient temperature. Question 118. A 25 kV underground cable splice has failed twice within 6 months at the same location. What systemic issue should be investigated beyond the splice itself? A. Whether a different color of splice kit was used the second time under standard operating conditions. B. Whether the splice was installed on a Monday versus a Friday as determined by the initial assessment. C. Whether the cable was manufactured in a different country than the splice kit components used for the repair. D. Whether the cable trench backfill has adequate thermal resistivity and whether the cable is overheating due to poor heat dissipation. The correct answer is D. Repeated splice failures at the same location indicate a systemic issue beyond workmanship. The most critical investigation is whether the cable trench backfill has adequate thermal resistivity to dissipate heat. Poor thermal backfill causes localized overheating that degrades splice insulation, leading to recurring failures. Splice kit color, day of installation, and manufacturing origin are not relevant engineering factors in splice performance. Question 119. When preparing an underground cable end for a new splice after cutting out a faulted section, what must be done to the cable insulation layers? A. The entire cable should be stripped bare of all insulation for 2 meters on each side of the splice. B. Each insulation layer must be stepped back to specified dimensions using the splice kit instructions. C. Only the outer jacket needs to be removed, the inner insulation layers remain intact. D. The cable insulation should be heated with a torch to soften it before the splice components are applied. The correct answer is B. Underground cable splice preparation requires each insulation layer to be carefully stepped back to precise dimensions specified in the splice kit instructions. The jacket, insulation screen, primary insulation, and conductor screen must each be removed to specific lengths to ensure proper stress control and insulation within the splice body. Stripping all insulation for 2 meters is excessive and destroys the cable. Leaving inner layers intact prevents proper splice geometry. Heating with a torch can damage the cross-linked polyethylene insulation. Question 120. When patrolling a transmission line after a trip event, what is the primary method used to narrow down the fault location before dispatching a field crew? A. Reviewing fault recorder data from the substation relays to determine the approximate distance to the fault based on impedance measurements. B. Driving the full length of the line at highway speed without stopping according to standard operating procedures. C. Calling nearby customers to ask if they heard a loud noise following the recommended service protocol. D. Checking social media for reports of power outages in the area as outlined in the maintenance work order. The correct answer is A. Fault recorder data from substation relays provides impedance-based calculations that indicate the approximate distance to the fault from the substation. This information narrows the patrol area significantly, allowing the technician to focus on a specific line section rather than patrolling the entire route. Driving at highway speed without stopping misses visual indicators. Customer calls and social media may provide supplementary information but are not the primary technical method for fault location. Question 121. What distinguishes an underground transmission cable fault from a distribution cable fault in terms of testing and locating difficulty? A. Underground transmission cables are always shorter in total length than distribution cables as per the applicable safety requirements. B. Distribution cables use copper conductors while transmission cables use aluminum conductors exclusively. C. Transmission cables operate at higher voltages with thicker insulation, requiring higher energy test equipment and more precise fault location. D. There is no difference in difficulty, the same equipment and methods are used for both voltage levels. The correct answer is C. Underground transmission cables operate at significantly higher voltages than distribution cables and have correspondingly thicker insulation layers. Locating faults in these cables requires higher energy test equipment, higher voltage thumpers and TDR units, and more precise fault location techniques due to the greater cable complexity. Cable length varies by installation, not by voltage class. Both transmission and distribution cables may use copper or aluminum. The equipment and methods differ significantly between voltage levels. Question 122. During emergency restoration of a transmission line after a storm, what temporary structure is used when a permanent replacement pole or tower cannot be installed immediately? A. A wooden sawhorse placed under the conductor span following the site-specific work procedures. B. A temporary guide-wood pole or steel gin pole set at the damaged structure location. C. A stack of concrete blocks supporting the conductor as per the applicable industry standards. D. The conductors are laid on the ground until permanent repairs can be made. The correct answer is B. A temporary guide-wood pole or steel gin pole is set at the damaged structure location to support the conductors at a safe height and maintain adequate ground clearance until a permanent replacement structure can be installed. This allows the line to be returned to service quickly during storm restoration. Sawhorses and concrete blocks do not provide adequate height, structural support, or insulation. Laying conductors on the ground creates an extreme public safety hazard and prevents re-energization. Question 123. When performing a live line repair on a transmission conductor using a hot stick, what factor determines the minimum length of the hot stick required? A. The voltage of the line, which dictates the minimum approach distance that must be maintained. B. The height of the conductor above the ground as determined by the initial assessment. C. The diameter of the conductor being repaired based on manufacturer recommendations. D. The weight of the tool attachment at the end of the stick according to industry standard practice. The correct answer is A. The minimum length of a hot stick is determined by the voltage of the transmission line, which dictates the minimum approach distance, MAD, that must be maintained between the worker and the energized conductor. The hot stick must be long enough to allow the technician to perform work while keeping the required electrical clearance. Conductor height affects climbing requirements but not hot stick length. Conductor diameter affects the tools used but not the stick length. Tool weight affects handling but not the minimum length requirement. Question 124. After completing a high-voltage splice on an underground transmission cable, what test is performed before the cable is returned to service? A. A continuity test using a standard multimeter to verify conductor integrity under standard operating conditions. B. A visual inspection of the splice exterior surface only as determined by the initial assessment. C. A load test by energizing the cable at full system voltage with the maximum rated load connected. D. A high voltage withstand test applied at a voltage above the cable's operating level to verify insulation integrity of the splice. The correct answer is D. A high voltage withstand test, HIPOT, is performed after splice completion to verify the insulation integrity of the new splice before the cable is returned to service. The test voltage is applied above the normal operating level for a specified duration to stress the insulation and confirm it can withstand normal operating conditions plus transient overvoltages. A continuity test only confirms conductor connection, not insulation quality. Visual inspection cannot detect internal voids or contamination. Energizing at full voltage without testing risks immediate splice failure. Question 125. When repairing an underground transmission cable in a manhole, what atmospheric testing must be performed before crew members enter the confined space? A. Temperature and barometric pressure readings only, following established workplace procedures. B. A visual check for standing water is sufficient as outlined in the job safety analysis. C. Testing for oxygen level, combustible gases, and toxic gases using a calibrated 4-gas monitor. D. No testing is required if the manhole cover has been removed for more than 1 hour. The correct answer is C. Before entering a manhole or any confined space, atmospheric testing must be performed using a calibrated 4-gas monitor to check oxygen levels, must be between 19.5% and 23%, combustible gas concentration, must be below 10% of the lower explosive limit, and toxic gas levels, hydrogen sulfide, carbon monoxide. Manholes can accumulate hazardous gases from decomposing organic material, leaking gas mains, or cable insulation breakdown. Temperature and pressure readings do not address atmospheric hazards. Visual water checks do not detect gases. Removing the cover does not guarantee adequate ventilation in all manhole configurations. That's all the questions for today. If this helped you prepare, subscribe now and hit the bell. We post exam prep for all Red Seal trades. Visit questionbankhub.com for the complete study guide with additional practice questions. Good luck on your Powerline Technician Red Seal exam. You've got this.